In the scenario of an open utility company service drop neutral, the presence of a low impedance Ufer system plays a crucial role in maintaining electrical safety and ensuring the proper operation of overcurrent protection devices. To fully understand this, let's delve into the principles of grounding, fault current paths, and the specific contributions of a Ufer system. A grounding system's primary function is to provide a low impedance path for fault current to return to the source. This path is essential for the fast and reliable operation of overcurrent protection devices, such as circuit breakers and fuses, during ground fault conditions. A ground fault occurs when an ungrounded conductor comes into contact with a grounded surface or equipment. Without a low impedance grounding path, the fault current would be limited, potentially preventing the overcurrent device from tripping quickly or at all. This can lead to dangerous voltage levels on equipment enclosures, increasing the risk of electrical shock and fire. The National Electrical Code (NEC) mandates specific grounding requirements to ensure electrical safety. Article 250.4 explicitly states that the earth shall not be considered as an effective ground fault current path. This means that relying solely on the earth to carry fault current is not sufficient to provide the necessary protection. The earth's impedance is too high and variable to ensure the rapid clearing of ground faults. Therefore, a dedicated low impedance grounding path is required. An open neutral condition occurs when the neutral conductor of a power distribution system is broken or disconnected. This can happen in the utility company's service drop, which is the overhead or underground cable that connects the utility's distribution system to the building's service entrance. When the neutral is open, the voltage balance between the phases and the neutral is disrupted. This can lead to voltage imbalances and abnormally high voltage on some circuits, while others experience low voltage. This voltage imbalance can damage electrical equipment and create unsafe conditions. Now, let's consider the role of a Ufer grounding system in mitigating the effects of an open neutral. A Ufer ground, also known as a concrete encased electrode, is a type of grounding electrode that is embedded in concrete. It typically consists of a length of bare copper conductor, at least 20 feet long, encased in a concrete foundation or footing. The concrete provides a large surface area for contact with the earth, resulting in a very low impedance connection to ground. When an open neutral occurs, the Ufer ground provides an alternate path for neutral current to flow back to the source. This helps to stabilize the voltage on the grounded conductors and reduce the voltage imbalance caused by the open neutral. The low impedance of the Ufer ground ensures that a significant amount of fault current can flow in the event of a ground fault. This is crucial for the proper operation of overcurrent protection devices. In the absence of a Ufer ground or another effective grounding system, the fault current may be limited by the impedance of the earth. This can prevent the overcurrent device from tripping quickly, allowing the voltage on the equipment enclosure to rise to dangerous levels. The presence of a low impedance Ufer ground ensures that the fault current is high enough to trip the overcurrent device quickly, minimizing the risk of electrical shock and fire. Furthermore, the Ufer ground helps to prevent premature tripping of overcurrent protection devices. In an open neutral condition, the voltage imbalance can cause some circuits to experience abnormally high voltage. This high voltage can cause the current in these circuits to increase, potentially tripping the overcurrent devices even if there's no actual fault. The Ufer ground helps to stabilize the voltage and reduce the voltage imbalance, preventing these nuisance trips. Here's a more detailed explanation of how the Ufer system provides a low impedance path for fault current. Firstly, the large surface area of the concrete encased electrode provides a very low resistance connection to the earth. This low resistance allows fault current to flow easily from the equipment grounding conductor to the earth. Secondly, the concrete surrounding the electrode helps to maintain a stable and consistent connection to the earth. The concrete protects the electrode from corrosion and prevents the soil from drying out, which can increase the resistance of the connection. Thirdly, the Ufer ground is typically connected to the building's grounding electrode system, which includes other grounding electrodes such as ground rods and water pipes. This interconnected grounding system provides multiple paths for fault current to flow, further reducing the overall impedance of the grounding system. In summary, the Ufer grounding system provides a low impedance path for fault current to flow in the event of an open neutral and a ground fault. This low impedance path helps to reduce the voltage rise on the grounded conductors, prevent premature tripping of overcurrent devices, and ensure the fast and reliable operation of overcurrent protection devices during ground fault conditions. This is essential for maintaining electrical safety and protecting equipment from damage. It's important to note that the effectiveness of a Ufer grounding system depends on several factors, including the size and length of the electrode, the type of concrete used, and the soil conditions. A qualified electrician should be consulted to design and install a Ufer grounding system that meets the specific requirements of the installation. Here are some additional points to consider regarding Ufer grounding systems. 1. Ufer grounds are particularly effective in areas with poor soil conductivity. In areas with dry or rocky soil, the earth's impedance can be very high, making it difficult to establish a good ground connection. The concrete encased electrode of a Ufer ground provides a large surface area for contact with the earth, even in poor soil conditions. 2. Ufer grounds are required in some jurisdictions. Some local electrical codes require the installation of Ufer grounds in new construction. This is because Ufer grounds are considered to be a very reliable and effective grounding method. 3. Ufer grounds can be used in conjunction with other grounding electrodes. In some cases, it may be necessary to supplement a Ufer ground with other grounding electrodes such as ground rods or water pipes to meet the required grounding resistance. 4. Ufer grounds should be inspected periodically. Like all grounding systems, Ufer grounds should be inspected periodically to ensure that they are still functioning properly. The inspection should include a visual check of the electrode and the connections, as well as a measurement of the grounding resistance. Now let's talk about some practical implications. If a building has an open neutral and relies solely on the earth for grounding, the voltage on metallic parts of electrical equipment could rise to dangerous levels during a fault. This poses a significant shock hazard to anyone who comes into contact with the equipment. However, with a properly installed Ufer ground, the fault current will have a low impedance path back to the source, causing the overcurrent device to trip quickly and to energize the circuit. This significantly reduces the risk of electrical shock. Furthermore, the voltage stabilization provided by the Ufer ground can protect sensitive electronic equipment from damage due to voltage fluctuations caused by the open neutral. Voltage fluctuations can cause malfunctions, data loss, and even permanent damage to electronic devices. The Ufer ground helps to maintain a stable voltage, protecting these devices from these harmful effects. It is crucial to emphasize that the installation of a Ufer ground is not a substitute for proper wiring practices and regular electrical inspections. It is an additional layer of protection that enhances the overall safety and reliability of the electrical system. All electrical work should be performed by qualified electricians who are familiar with the NEC and local electrical codes. Regular electrical inspections can identify potential problems before they become serious hazards. In conclusion, the Ufer grounding system plays a vital role in mitigating the effects of an open utility company service drop neutral. By providing a low impedance path for fault current, it helps to reduce voltage rise, prevent premature tripping of overcurrent devices, and ensure the fast and reliable operation of overcurrent protection during ground faults. This contributes significantly to electrical safety and the protection of electrical equipment. The NEC mandates the use of effective grounding systems, and the Ufer ground is a valuable tool for achieving this goal, especially in situations where the earth's conductivity is poor or an open neutral condition exists. The key takeaway is that a well-designed and properly installed grounding system, including a Ufer ground where appropriate, is essential for a safe and reliable electrical installation. This includes understanding the purpose of grounding, the dangers of an open neutral, and how a Ufer ground provides a low impedance path for fault current. This knowledge empowers individuals to make informed decisions about their electrical systems and ensure that they are properly protected. Remember to consult with a qualified electrician for all electrical work and to schedule regular electrical inspections to maintain the safety and reliability of your electrical system. The combination of proper wiring practices, regular inspections, and an effective grounding system, including a Ufer ground when needed, provides the best possible protection against electrical hazards. Therefore, the Ufer ground system does indeed offer substantial protection with an open utility company service drop neutral.